Hello everyone, welcome to another live astronomy from North Essex Astro. We are going to take a look at a few objects again tonight. This will probably be the last one that we do of an evening because we're having to start later and later as the nights get lighter. But hopefully you'll see some interesting things tonight, and we'll have some other events coming up on our page. So please follow us if you haven't already, and we'll give you some more interesting things to look at over the next couple of months. Okay, so getting started. The first thing we are going to take a look at tonight is the planet Venus. So without further ado, I'll switch over to our planetarium to give you an idea of where Venus is in the sky. So if you go outside at the moment, obviously you'd have to leave me, but feel free if you want to. Take a look out towards the west where the sun has set. So if we look where the sun set, which is about here, you should see up in the sky a really, really bright object. That is the planet Venus. That's one of our nearest neighbours in the solar system. It's often the third brightest object in the sky after the moon and the sun. It's not quite as big as the Earth, but it's quite a large planet. It's very hot there. We like to tell people it's about 500, 600 degrees Celsius on the surface of the planet. That's hot enough to melt lead. You really want to go there on your holidays. Even if you manage to survive the temperatures, it's incredibly high pressures. The atmosphere is very, very dense, which is why Venus is so hot. And the pressure is so great that it'd be like being at the bottom of the sea. So you'd actually be crushed by the pressure as well as boiled by the heat. And if that wasn't bad enough, it also rains sulfuric acid. So really not a pleasant place to go. However, a very beautiful object to take a look at. So if we switch over to our live view, what you will see, this is my telescope now, which is pointing at Venus. You will see that it's quite obviously not a star. It's a planetary object. If you can, it's a bit hard to see because it's really, really bright. So it's quite hard to image. I've got this telescope and this camera set on the shortest possible exposure I can. It's not a very big telescope either, but even so, it's quite bright. But you should be able to see that this is almost a half moon shape. It's a little bit blurry because we're taking such short exposures, but it's effectively a half moon shape because the sun is on this side. So this image is actually upside down. So if we go to the planetarium view, you can see in the planetarium that the sun is set down here. So the lit side of Venus is the sunward side of Venus, so it's actually down this side, and the dark side is the side that's pointing away from the sun. But when we switch to our live view, you can see that the image is flipped upside down. So effectively, this is down towards the ground in this direction. The sun is on this side, illuminating this half of Venus, and on this side, we're in the night sky side of Venus. It's dark. Now, Venus is nearer to the sun than us, so it's actually catching us up on its journey around the sun at the moment. A bit like if you're on a racetrack, if you're doing the 400 meters, the athlete in the inside lane has to travel less distance, so they'll be traveling quicker and they'll overtake the ones on the outside. Venus is doing exactly that. It's overtaking us on the inside. As it gets closer to us, the angle will change, and it will actually change to much more of a crescent shape. A bit like a crescent moon. When the moon's new, you get that crescent shape. So it will go from being half illuminated to being crescent. It'll still be really bright in the sky, but it'll be less illuminated. If you look at it through a small telescope, you can very obviously see that it's not a star. You can see the planet shape, and it's a very beautiful sight as it gets to being more of a crescent. You can't see much detail on the surface of Venus. It's completely covered in a thick blanket of white cloud, which is why it's so bright. It's very, very reflective. If you take images in ultraviolet or in infrared, you use special filters and sort of use them together, you can get some of the details of the cloud tops out. But through a normal telescope and through this telescope, all we see is white. So really not a lot of detail to see, but you can be sure that it's definitely a planet. Now, what we're going to do is we're going to stay with Venus, but we're actually going to zoom out now. So Venus is now this tiny little object down here. It looks really, really small, but it is a planet not quite as big as the Earth, but it's really big. And we're going to change our exposure. So we're going to go up to a much longer exposure. So we're going to go up to maybe I would say let's go for 5 seconds so it's not completely crazy. Go to a 5-second exposure and we'll start stacking up the images. And what we will get in a moment or two, we give it a chance, just clear that and let it start again. What you will see is this really bright object down here. This is Venus, and above it we have the Pleiades, or the Seven Sisters. Again, if we switch over to our planetarium view, we can see that Venus is here in the sky, and at the moment Venus is actually travelling through the Pleiades. It passed right through the middle of it last night. It's just moved out now. So this is the Pleiades here. These are the Seven Sisters. Being that we're in Essex and we like our cars in this part of the world, if you look on the front of a Subaru, you'll see a shape that's fairly similar to this, because the Japanese name for the Seven Sisters or the Pleiades is Subaru, so that's what the Subaru badge is. If we go back to our live view again, you can see here it is. It's on its side a bit here. It almost looks like, you remember the plough which we've looked at before. It almost looks like a mini version of the plough. A little handle here and some stars here. Now these stars are quite bright, and in a normal sky, when it's dark, you'd actually be able to see them very, very easily with the naked eye. A little patch of nice bluey stars all quite close together. It's a good test of your eyesight. If you can see 7 stars, you're doing okay. If you can see more than that, you're probably doing really, really well. You might be quite young because you've got great eyesight. As you get older, you see fewer of them. But they're all related, the stars of the Pleiades. They're all sort of really hot blue-white stars. They formed about, I would say, about 100 million years ago. And if we kind of keep imaging this and stacking the images up, eventually what we would start to see is some nice dusty stuff would appear around the stars. So again, if I zoom in a bit and go up this way a bit to some of these stars up here, you can actually start to see this stuff here. This is not dirt. This is actually dust that's around these stars. The blue light from the stars is actually reflecting off the dust, and you can see a bit more of it down here. If I switch over to an image that I took a couple of years ago, this is a nice image of the Pleiades, and you can see that kind of plough shape almost on the kind of here. You can kind of see the handle and the little stars. It's much smaller than the plough. It's a little patch of stars close together. But you can see all of this streaky stuff here. This isn't dirt on the telescope. This is actually the dust that was part of the nebula that these stars form from. Now, stars form in nebulas of gas and dust. We looked at the Orion Nebula last time out. The Orion Nebula has lots and lots of gas there. There is also lots of dust. The Pleiades are quite a bit older than the Orion Nebula, but they would have been much closer when they first formed. Very similar to the Orion Nebula, which has lots of really bright stars very, very close together in the middle, and that dust is still hanging around in the Pleiades, whereas the gas which the stars formed from has already all been blown away. The stars are very hot when they're young. They heat the gas up and it flies off into space. The dust eventually will go as well, but it's much heavier, so it takes a lot longer for it to blow away effectively. And this dust is the stuff that planets and rocky planets form from. It also ends up inside the star and inside the other planets, but planets like the Earth and Venus and Mars would form from this stuff. You can also see a nice little image of Venus that I took a few weeks ago. Again, it's fairly similar phase, about half full. But Venus is it's much brighter. So you can see that the Pleiades is actually quite bright. If you get a nice picture of it, Venus is much brighter. I mean, just to give you a comparison, the Pleiades is quite a long way away. I'll find out how far for you. Just bear with me a second. So distance to the Pleiades is distance is about 444 light years away, which is quite a long way away. Whereas Venus is only 107 kilometers away. 107 million kilometers away, sorry, not 107 kilometers away, that would be pretty close. 107 million kilometers away, which is a little bit further away than the sun at the moment, but it's actually racing towards us and getting closer at the moment. The light from Venus at the moment is taking about 10 minutes to get to us. So again, going back to the live view, if we zoom out again, get the whole thing in, you can see Venus down here, 107 million kilometers away, really bright because it's reflecting the sun. The Pleiades cluster is about, say, 444 light years away, quite a bit more distant. But it's an easy object to find once you know where to look. So now Venus will continue to move away from the Pleiades. Each night it will get further and further away as we both travel around the sun. The Pleiades should be still visible in the evening sky for a few weeks yet before it starts to set, before the sun's gone down completely. So a nice one to look out for, pretty easy to find. So that's our first object for the night. So what we'll do now is we're going to take a look and see if we can find another object. So just bear with me a moment. We've got to do the usual messing around here. We've got to disconnect cameras. We've got to change software just to find our next object. Shouldn't take too long, fingers crossed. Not too far away in the sky. So we are going to go and take a look for it. Bear with me a moment. So we'll switch to live view, see what's going on. Second, so we are now moving telescope. Again, we can use our planetarium, our planetarium software, find out where our telescope is pointing, and it has moved. So we were over here a bit, where Venus is, really bright. Gone past Orion, which is down here. We're now in this area of the sky here, which is just a bit further over from Orion. So again, if we look for Orion's belt, we look in the planetarium, zoom out, we were here, now we are going over here. So if we search, find, there it is. So the Rosette Nebula is here. Again, remember we saw Orion, which is sort of somewhere just across from Venus. So we've got Orion's belt here, we've got Betelgeuse, we've got Rigel, there's his shoulder, and just a bit across from his shoulder is where the Rosette Nebula is. We now go back, we've found our object. What we will now do is we will again change software to the software that we need, and we will start taking exposures and stacking them. We will do no expose 10 seconds because it's a bit dimmer, this object. Wait for some exposures to come down. Here we go. Right, so what we can see now, we go to the live view, this is the centre of the Rosette Nebula here. These are actually the stars that have formed in this nebula. You may just be able to start seeing something appearing around the outside here. Again, if we go back to the planetarium view, take a look at that. We'll zoom in a bit further. As I say, remember where we are in the sky. Sun sets in the west over here. We've got Venus above it. Go round towards the south to the left of Venus, you'll find Orion. Orion's belt is here. Remember the Orion Nebula that we looked at last time is down there. We go up to where Betelgeuse is, the red star that's up in Orion's shoulder here. A bit further across, there isn't anything really obvious in this area, so I would say just take the distance between Orion's shoulders, kind of extend it out a similar sort of distance, and you'll be in the right sort of area. Not an object that's particularly easy to see even through a medium-sized telescope, but this is where we are here. Now if we go back to the live view again, hopefully something will start building up. Right, just software going on here. So again, if we just yes, we can start to see the Rosette Nebula appearing now. So similar to the Orion Nebula, very similar processes. So it's a big cloud of hydrogen gas, and effectively these stars in the middle are formed by parts of that gas collapsing down into much smaller clumps, and then eventually they get cool enough and they compress together to form new stars. And when the compression makes the centre of the star hot enough, it will actually heat up. Nuclear fusion starts, then the star lights up. Once the star is lit up, then that starts to heat up the surrounding gas, which is what we can see here, making it glow, but also it starts to push it away. So again, this is another one of these kind of bubbles. I mean, it looks quite, we go in maybe to 100%. What we need to do is we start mixing, of course. Give me a second. So, yeah, we can see this actually has been trailing a little bit because we haven't been tracking as accurately as we could do. Yeah, we'll just zoom out a bit more. You start to see that the actual Rosette Nebula is forming now. So we can have a look at a photograph that I took of it a while ago. So if we switch to this view, move on. This is the Rosette Nebula. Again, taken through not this telescope, but a similar telescope with the same camera that we're currently using. You can see the stars in the middle here. This is actually, you know, where all the new stars form. They're really hot. They're heating up all of this gas. So we've got hydrogen, we've got sulfur, we've got oxygen here. It's mostly hydrogen, and that's actually making the gas glow, and it's blowing it away. Now, again, it looks like it's a sort of flat 2D object, but what you actually need to imagine is this is a big fishbowl, effectively, and the stars are in the middle of the fishbowl, and what we're looking at is bright bits of the edges, where we're looking through the edges of the fishbowl, so we're looking through much more gas, and they're really, really bright. As we come towards the middle, we're looking through just a much thinner layer of gas, so we can see inside, and that's why it has that kind of circular ring around it. It's not a ring, it's actually a bowl shape, and the gas is in the middle, blowing a big bubble of empty space in there. The other interesting thing that you may be able to see here is these little dark lines. These are the much cooler regions of gas and dust, and it's at the ends of these that little blobs form where the actual stars are actually born. So they actually, because they're surrounded by gas, they tend to dust tend to cool down. The gas inside collapses enough so actually gravity starts to do its work and pull the gas together and form these new solar systems. So it's these little blobs here, right at the ends here, that where these new stars will tend to form. And so we go back and take a look at this again. It's coming out. So you can see this the long exposure image that I was showing you there. That's probably about 3 or 4 hours of exposures. What we've currently got here is just a bit less than 5 minutes worth of exposure. So you won't get a huge amount of detail out of it. But again, it shows why it's quite hard to see this with the telescope or the naked eye, particularly in a sort of light polluted area. If you had the right sort of filters, you might be able to pick some of these faint nebulas up. It's by no means easy. So that's the Rosette Nebula again. So maybe if we just take a look where we are in the sky, just to remind ourselves. So the Rosette Nebula is here, just across Orion's shoulders, and same width again between the shoulders, and that's where we are. So that's where the Rosette Nebula is. So that's our second object for the night. So we've had a nice look at that. So what's next? Well, what we'll do is we'll stop this, see if we can find another object. So what I'm going to do again is I'm going to change my software. This one, I'm not sure whether we'll be able to see this one because it might be hidden behind a tree, but I couldn't check that earlier today. So what I will do is we'll try our best, go to it, see what we get. You may or may not get anything. Really depends. Again, so if we switch to our live view, The software is working away. The telescope's on the move, taking a picture, work out where we are in the sky. We may or may not be in the right spot. Some of these objects are being requested by the members of the society today, so I've done my best to try and oblige them and show them things. Okay, great, so we've got it. I think we've also got the moon quite nearby, so you may see some brightness coming in from the side. So I'll disconnect that bit of software, switch back to this one, back to here. I haven't got that. Oh, bear with me a second. Right. Camera connect. And we're backing these images up. So got second. Okay. Right, okay, so we'll let that do its business for a little bit. We'll let that carry on stacking. You can start seeing some interesting objects appearing here. So as I say, you can see something here and there's something here, which we'll talk about. You can also see this here. This is the moon intruding on our scene, I think. May just be some light pollution from somebody's house, I'm not quite sure which. Right, okay, so if we switch to our planetarium view again, where have we gone this time? So we were in the Rosette Nebula. Now we're going to look for our next object, M46. Again, not too far away, so just to get you bearings here. Remember, we started over here, looking to the west, Venus. We've come round, found Orion, found the Rosette Nebula, which is up here. Now, if we keep going around, almost looking due south now, so we would have Venus pretty much on our right-hand side over there. We're looking at M67. Sorry, beg your pardon. Right, I'm looking at M46, not M67, M46 and M47. So we've got two for the price of one here. So we've got two star clusters. This is M46 here, and this is M47. Sorry, this is M46 here. This is M47 here. We go back to the live view. You should start to see. Again, if I just brightness get here, we've got the two objects here. So we've got M46. We've got M47, and they're both star clusters. So M46 is a classic sort of open star cluster. It's got lots and lots of stars, and it's about 4,900, nearly 5,000 light years away, and it's got about 500 stars in the cluster. Double check which one we're looking at here. So that's M46, which is one at the bottom here. M46. As I say, that is 5,000 light years away, 4,900 light years away, 5,000-ish, 500 stars, and it's about 250 million years old. So, lots and lots of stars in this cluster, and then we've also then got M47, which is this one up here. So this is M46, this is M47 up here, and that is actually quite a bit nearer, I believe. I think that's right. Let's double check my facts. I'd like to have my facts straight for you here. Yeah, it's only about 1,600 light years away, so it's so 5,000, about a third of the distance away. So this one here is about 3 times further away than this one here. Again, it's a cluster of stars. It's again got about 500 bright stars in it. They're again fairly similar to the stars in the Pleiades. They're mostly hot blue stars. So M47 is much for is right. M47 is much nearer to us. M46 is much further away. So got those two clusters there. Again, these would be nice, easy objects to find in the telescope. Quite low down in the sky, so you need a reasonably good horizon to see it. But again, if we just take a look at where we are, so again, if I just select M46 and zoom out in the planetarium, you'll see that. So this is M46 here, M47 there. It's not too far away. So again, if you find Orion's belt, we go down towards Sirius, which is the brightest star in the sky. Really obvious, not as bright as Venus, but really it's still bright blue and quite twinkly. And M46 and M47 are a bit above and to the left of Sirius. And you should be able to get both of those in the field of view of a pair of binoculars quite easily. A small telescope would start to show the stars quite nicely. So that's one of our members' requests, to see M46 to M47. We'll just see what we can get out of that. So yeah, so it's pretty bright over here. Okay, so that's M46 and M47. So what's our next object tonight? Take a look. Right, now this one should be much easier to find. I am hoping that we will be able to find it fairly quickly. Easy to find, so bear with me a second. Right, okay, it's going to take a little while to get there because, as I've explained before, with these equatorial mounts, when we cross what we call the meridian, so it's effectively the sort of noonday line in the sky, if we're looking at one side of it and then we want to look on the other side of the meridian, then the telescope has to go the long way around the sky to end up pointing in the right direction. So even though we're not moving that far, it will take a minute or two to get there. But this is a nice obvious object, hopefully, so we're getting there now. We won't be long. Fingers crossed. Down, so yeah, we've got really reduce our exposure now. Bear with me a minute, and we can get this thing. Okay, there we go. Right. Exposure now. I'll show you what we're looking at. This should be pretty obvious to anybody who's looked in the sky. You should have a fairly good idea. What we might do is try and I just need to jog this a bit nearer to the middle of the screen and zoom in a bit. So we're looking at the moon, obviously. I think it should be fairly obvious to you all. We'll zoom in a bit. Just that. There we go. The exposure even more because the moon is really, really bright tonight. We're not a full moon yet, but we're getting there. Like that. Okay, so we've got a nice view of the moon here. This one should be pretty easy to find. Hopefully, shouldn't need to really give you too much of a clue where to look if you go outside. Pretty much due south right now. We've got the moon. If we take a look in the planetarium, there it is, sitting nice and high in the sky. Great for being out and having a sort of nice romantic evening in the garden, but not so great if you're an astronomer because it tends to drown everything out. The moon's currently in the constellation of Leo, the lion, down near its feet. Again, if we take a look at the live view, we can see some nice views of the moon here. We can see some of the big ray craters. This crater here. So we switch to live view. This ray crater here is called Tycho, and what you can see is these lines stretching out in all directions. It's actually material that was ejected from the crater when a large object crashed into the moon and made the crater. Stuff was thrown out all the way across the moon in these stripes, and you can see a number of other craters have similar features. If you're observing the moon, the best place to look is what we call the terminator. That's the line between the night and the day side of the moon, constantly moving as the moon go around the sun, the moon goes around the earth. But near the terminator you get much more detail. You can see these lovely rims of craters, you can see mountain ranges, you can see the edges of what we call impact basins, and we've got some big what we call seas or maria. These aren't actually seas, they were thought to be seas by people who first observed the moon a long time ago when they didn't really have any idea of what it was made of. We now know that actually these are younger regions of the moon, so the bits with lots and lots of craters on them are quite old. So towards the end of the beginning of the solar system, about 4.5 billion years ago, there was a period called the Late Heavy Bombardment, where it was a bit of a shooting gallery and lots of comets and asteroids crashing into all of the planets and the moons, including our moon, and made loads and loads of craters. And towards the end of that process, there were some really big impacts, basically melted the whole surface of these impact basins. Lava welled up and effectively, a bit like kind of filling in your potholes, resurfaced these areas and wiped out the earlier craters. You can just see some of them around the edges. So the bits where are lots of craters, we know these are the much older areas, and these bits here, although they're still really old, are relatively younger because they've basically been resurfaced. There hasn't been as many impacts over the rest of their life. They have far fewer impact craters on them. So the moon, always a nice object to look at through naked eye, through a small telescope, through a pair of binoculars. As I say, probably best to look at it while it's not full, because that's when you see the detail. When you look at it during full moon, the one thing that you can see really well is actually the ray craters. So you can see these craters and the rays are really bright and obvious, stretching out, but pretty much everything else is just pretty bland. Whereas when it's like this, you can get in much closer, you can see some of the details. So perhaps we just try and take a little bit of a closer look. Zoom in a bit more. You can see, as I say, there we go. Start to see some of the craters, and you can see when you see them with the light edge on, this is just basically where, from the point of view of the surface, the sun is in the process of rising here. You can see much more of the detail. You can see the mountain ranges and the edges of the craters. So much better time to look. So that's the moon. We're going to now try for another object. We can disconnect the camera, go back to our other software. Bear with me. Right, I'm going to go over here. Again, take a moment or two. So again, if I we need to connect the camera, that won't work. There we go. Camera is connected. Now if we go to, we're in the process of again moving the telescope across the sky. We're on the right side of the sky now, so it shouldn't take so long. I'll show you what we're going to take a look at. Planetarium. So again, if I do the planetarium view, we zoom out, go over here, going to be looking at Virgo cluster, or part of the Virgo cluster. It's not actually in Virgo, but you can see Virgo here is the next constellation down from Leo, if you know your horoscopes. And we've got Coma Berenices here, which is Berenice's hair. And just between the two, we've got, see all these red blobs here. These are all galaxies. This is the Virgo cluster. It's a huge cluster of galaxies. And stop that. And got place. There we go. Right, camera again. Here, with me a second. Camera motor up to 10 seconds. Okay, so while we're waiting for that to happen, going back to the planetarium, sorry, just two jobs at once, we're actually going to be looking at a chain of galaxies called Markarian's chain. This is part, you can see, as I say, we zoom in here, more and more galaxies appear. This is the nearest big pile of galaxies outside of our sort of local area. We're quite a long way away from it, but it still has a big gravitational effect on everything nearby. Vast numbers of galaxies here. We're going to be taking a look, hopefully, at a whole bunch of them in a moment or two. If this is going to is or it isn't. Right, it is trying. Yes. Tricky. That. Give it a minute here. Right. Run for a minute. So while we're letting that run, we'll take a look at, as I say, at the planetarium here. There are loads of galaxies in this area. We've got this whole bunch here. About 6 out of this whole bunch here actually are related. It's been shown that they're all moving through space in roughly the same direction and the same gravitational influence. This is a lovely thing to look through a medium-sized telescope, because you can start at one end, find a nice bright galaxy, and you just hop from one to the next, to the next, to the next. We can get a very nice view, and they are starting to appear now. So we'll just switch over to live view. Again, quite hard to see because we've got a really bright moon out there tonight, but you can start to see. So here is Markarian's chain. This is this whole load of galaxies here. Lots of these other fuzzy blobs are also other galaxies in the Virgo cluster. To give you an idea, again, I've got a nice picture that we prepared earlier. So this is Markarian's chain here. This is the whole thing. Again, you can see this actual chain of galaxies, but we've got some more here. We've got another one up here, one over here, another galaxy over here, and there's loads and loads of these actually. A lot of these little blobs are actually galaxies. There's one there, there's one there. That's a galaxy, that's a galaxy. It is really quite a massive collection of galaxies. So quite hard to pick out in some ways, but you can see. So again, if we compare this to so if you just say focus on these two here, and you've got these two skinny little galaxies above and below. So let's show you what we're looking at here. Sorry, we've got these two galaxies here. We've got these two skinny little galaxies here. So you've got two bright ones, these two skinny ones. We go back to the live view. You can see the same thing here. So those are those two galaxies there. There are two skinny ones, and there's the rest of the chain going around here. This streak here is actually a satellite passed through the view. Here's that other galaxy that we were looking at. I want to say it's M43. It might not be. It might be the wrong one. Let me just have a look in the planetarium. We can find out, can't we? Switch back to the planetarium view. Planetarium, we've got skinny ones here and here. M88, that's the one. M88 over here. The other galaxy in the view. So there's the chain. Again, it's a bit upside down, very a bit confusing, but we've got these galaxies, we've got the skinny ones. Go over here, we've got M88 back in the live view. same thing. So we've got the skinny galaxies, the two bright ones. There's the chain. Okay. So again, this is about 2 minutes of exposures with these galaxies. So a medium-sized telescope, sort of 8-inch telescope, you'll be able to see these. Not too difficult at all. So a nice dark sky. Again, I think as I was showing you the picture that I took of it before. This is sort of a similar telescope with a Canon DSLR photographs. It's one of the first pictures that I took quite a long time ago, but it's a very nice image indeed. So that's Markarian's chain. So again, if we just take a look at where we are in the sky, let's just remind ourselves of that. If we zoom out, those in there, we need to find Leo. So easy to find at the moment. We've got the moon. We've got this backwards question mark shape. That's the head of Leo, and we've got body down below, and we've got the back feet. They're almost pretty much pointing down towards Virgo. Not a very easy constellation to pick much out in. Comet, again, not a very easy constellation to pick it out in. But you have actually got Arcturus here, which is a really nice bright orange star. That's quite easy to find. Remember our old friend the plough. When we use the plough, it's up here. So we've got the body and we've got the handle. Remember, we use the body to find the North Star, to find the Pole Star by following 2 N stars. We use the handle and follow it in a curve round. Keep curving round like this. We come to Arcturus, this bright orange star here, starting to rise in the east, and pretty much not 2/3 of the way from Arcturus to the back foot of Leo. That's where Markarian's chain is. But as I say, there are loads of galaxies. You could spend many nights just looking in this one area. The bigger the telescope you've got, the more you'll see. If you like to take astrophotos like I do, this time of year is called galaxy season in the Northern Hemisphere, because this is when all of this stuff is rising. This is when we can take lots of really nice galaxy pictures. There are absolutely loads of them in here. Maybe a quick few facts and figures about Markarian's chain. Been known for quite a long time, but it wasn't, sort of 1700s, late 1700s, early 1800s. It was identified, but really it wasn't proven to be a single sort of set of galaxies that were related by gravity until I think about 1959, I believe. So it's about 1959, early 1960s. It was proven that all these member galaxies were related. About 6 or 7 of them can definitely be proven to be moving in the same direction, so we know they're related. But everything in this cluster, they're all gravitationally bound. This is the biggest sort of chunk of matter and dark matter in our local area, so pretty much everything, including our Milky Way, Andromeda, or other local group galaxies, are all kind of being pulled around by being pulled towards the Virgo cluster, which is really massive. It's a long way away, though. I mean, we're talking, sort of several hundred light years. I think it was 50, 60. So yeah, distance to this one, pick out a galaxy, 46 million light years, 108 million light years, 75 million light years. So yeah, not too close, but still relatively close in galactic terms. You can still pick these galaxies out. There are lots of them there. Again, if we just quickly flip back to the live view, see what we've got. The longer you go with these things, the better your pictures get to find. We will just have a manual adjustment of the view here. That. Yeah, so you can definitely see the galaxies being picked out. They're mostly elliptical galaxies. Some of them, like these here, are spiral galaxies, quite edge on. but they tend to interact and merge. So the small spiral galaxies tend to interact with each other and merge together, and eventually when they bigger galaxies merge, they form what we call elliptical galaxies, which don't have spiral arms. They're sort of big, sort of egg-shaped things. Maybe not quite as interesting, but definitely bigger. So that was Markarian's chain. So that was our next object for the night. We just there. Right, we're going to find our next. And again, we might shuffling around with the software. You can find. For a bit. Yeah. Sky again, so we just checked. Camera first. On the move. Again, wait for the telescope to make its way across the sky. The next object we're going to take a look at is M51, the Whirlpool galaxy. So this is again an image that I took a while ago, again using the same camera we're using tonight, but with colour filters. It takes quite a long time because you have to take images through each of the colour filters in turn and join them together, which is not like using your sort of standard phone camera, but gives you a much better result in the long run. Now, we use the same camera, but we use a different telescope. It's a similar sort of size. The current telescope we've got 81mm. This telescope was doing 80mm, not quite as good a quality telescope, but still a pretty good telescope for what we're trying to do here. So again, if we just check, yes, okay, so we found the object. So we'll keep going. Crazy. Can be a bit of a nightmare sometimes. Some of this stuff can be quite wayward and challenging to operate. Right. Camera. Taking some pictures. Oh, okay. So again, we'll take a look at where we are in the sky here. Show you where we've gone. So we were over here. We've gone right the way around from west almost to east. We're going to carry on a little bit further up to our friend the plough. We all know where the plough is. It's on its side at the moment in the sky. Lovely sort of saucepan shape with the handle. We're actually going to go down here towards the last star in the handle, and this is where M51 is, the Whirlpool galaxy. Again, just to get you oriented, if you're not sure, if you've got a bit lost, remember we look to where the sun set, where Venus is towards the west. We then get Venus on our left hand side. We'll be looking north, and just up and to above north we've got the plough, sort of starting to go over the top now. Look for the body of the plough, look for the handle. If we go down to the handle and just across from the handle, we've got M51, which is here. Great. Okay, so we'll switch to the live view. There we go. So this is M51 in live. Zoom in a bit so you can see it. Lovely spiral galaxy. Quite lucky with this one because we're actually looking straight down on it from above. So here's the core of the galaxy, and these spiral arms wrapping all the way around M51. M51 is a very nice galaxy, called the Whirlpool galaxy for obvious reasons. You can see why. about 23 million light years away, so not as far as some of the other galaxies we've looked at. Can be seen with a pair of binoculars on a nice dark sky, but with an 8-inch telescope it's pretty easy to spot. With a bigger telescope you can start to pick out some of the shape. Now, the one interesting thing about M51 is there's got this little companion galaxy here. Now remember, we've talked about companion galaxies before. We've had this object here is another galaxy, so we've got Magellanic Clouds orbiting around us. Andromeda's got two small dwarf galaxies orbiting around it. M51's also got a dwarf galaxy, but as I've told you before, big galaxies grow by eating small galaxies, and we can actually see that process in action here. This little galaxy has strayed too close to M51, probably passed through it. You can see this streak here. This is actually a bunch of stars that's been ripped off of the companion galaxy and is now being absorbed by M51, and it will move away a bit and then it will come back again and it will get chewed up even more, and it will keep doing that till eventually it just ends up being nothing but a tiny little ball of stars in the center called a globular cluster, and the rest of the contents of the dwarf galaxy will have been chewed up by M51. Again, if we take a look at the image that we took, you can see it a bit more clearly here. What you can see is you can see the core of the galaxy here. You can see the lovely blue spiral arms. They are quite blue because they've been disrupted by the gravitational action of the dwarf galaxy passing through. It stirs all the gas up, starts causing lots of stars to form. It's been pulled away, and you can see this sort of gas and dust. You can actually see this lovely streak of dark brown dust that's also been pulled out. And you can actually see, and if you've got longer exposure, you can see it's quite long. There's this big tail of stars here. Again, this is all part of this dance of death that this little galaxy is going through. It's being eaten up by this bigger galaxy. So that's M51, the Whirlpool galaxy. Pretty easy to spot through a reasonable sized telescope. Now we're going to go for our last object of the night. So if we stop that one, what we will now do is we'll go here and stop that. Up. We've got one more object for you tonight. This is a nice interesting one. And get there. A second. So again, you can see that we're in the process of moving. Telescope scoots across the sky. And we're actually on the hunt for a comet. So what again I will do is show you where to look for this comet. Planetarium view. This may be a nice one soon. I'm going to search for it. This is Comet C 2019 at Y4 brackets Atlas. Normally comets are named after the people who discovered them, which was good in the old days because they were all found manually. So comets would have nice interesting names of people. These days most comets are found by computerized survey systems that are constantly scanning the heavens for dangerous objects. The Atlas system is one of those objects that's been set up to try and detect anything that might be on a collision course with the Earth, and they regularly find comets quite easily. So where are we in the sky looking at this comet? We're actually, we're pretty close to Plough. So again, if we kind of get the orientation we're familiar with, we're looking north. So the Plough is pretty much upside down and pointing down. So again, we've got the Plough here, the handle pointing at the North Star, and remember we said Cassiopeia is on the W shape, is on the opposite side from the Plough. So if you follow the pointers to the North Star and then keep going, you get to Cassiopeia. Well, kind of the comet is actually at the moment up between the two of them, sort of pretty much not quite up straight up from Ursa Minor from the pole star, but it is quite close. Let's see if we've found what we're looking for. Go. go. On in. Go. Yes, there we go. We've got it. So I'll switch over to the live view. So this object here is the comet that we're interested in. This C 2019 Y4. You can see it now. It's pretty much bright enough. If you've got a small to medium-sized pair of binoculars and you know where to look, you can just about see it now. It's not quite a naked eye object at the moment. A lot of people, again, as they always do with comets, every time they hype it up, it's going to be the comet of the century. There is a fair chance that it may brighten up over the next month or so, and it may become visible with the naked eye. However, there are no promises, and nearly every time people say those kinds of things, what actually ends up happening is that the thing dims, disintegrates, disappears, and generally disappoints. But you can see the head of the comet here, and you can see the tail of the comet stretching out behind it here. So this is the comet, and it's on its way around the sun. Now, the good thing about comets is that they actually move quite quickly. So every night it's going to be in a different position. And if we actually take pictures of it, I'll show you a picture that I've taken of Comet. Now this one was taken last week. So there are two versions of the picture. So on the left here, this is the colour version. It's quite difficult because, again, remember I said the camera that I use, I have to use lots of different filters to get colour. So basically I've had to do a lot of work to combine all of those colours to make this comet image. Comets tend to be quite green. It's the gas, and the ionised gas glows green around the head of the comet. You can just about see the tail coming out from the comet here. On this side, this is actually the same set of images, although I've used more of them in here. And instead of lining up all the stars to give us a sort of nice natural look, what I've done is I've just tracked comet each time that I've taken a picture. I line up all the comets, and over the course of an hour, you can see that the comet is actually moving. It's actually moving up the screen effectively. And because we're basically tracking the comet, the stars streak out downwards in this kind of lovely light speed type effect. And you can actually make quite nice movies of the comets. You can actually see them moving. So even over the course of an hour or two with a relatively small telescope, if you take pictures or you're just patient and make a little sketch where the stars are and where the comet is, look again an hour or two later, you can see that they visibly move quite quickly. It's one of the reasons they're quite challenging to image, because we tend to want to be tracking on stars which tend to just move across the sky in a nice predictable way. They're easy to track. Comets are a bit harder to track because they're actually moving independently. Now, Comet 2019 Y4, it's currently it's about 190 million kilometers away, so that is it's a bit further than the sun. It's about a quarter of the distance again from the Earth to the sun away. It means the light from the comet that we're seeing in our live view at the moment actually taking about 10 minutes to get to us. So again, if we just take a look again, if I just brighten this a bit here, yes, you can see now the tail is starting to appear more. The comet was brightening, which is why everybody's getting quite excited about it. It's started to sort of not quite dim, but it isn't getting any brighter, maybe dimming a bit. This isn't unusual. It might actually start to brighten up again. Now, comets are basically just big balls of snow and dust, and as they approach the sun, they heat up, and the gas in the snow, the sort of water and other ices of different types of gases heat up, and they start boiling away and throwing big clouds of dust out into space, which is why you get this big sort of blob called the coma. The nucleus of the comet might only be a couple of kilometers across, relatively small, way too small to see in its own right in a telescope of this size, or even a very large telescope. But because all this gas and dust is boiling off and forming this coma, we can actually see it. That's this bit here, and then the stuff that's left behind as it moves around on its orbit, and the sun actually ionizes the gas and blows it away. So the solar wind actually blows the gas and the dust behind the comet and forms this tail. Now, if it does become a naked eye object and gets really nice and bright, it could be very beautiful. For a change, most of the bright comets we've had in recent years have only really been visible in the southern hemisphere because of course they've taken around the sun. This one will be visible in the northern hemisphere with a bit of luck, because it's going to stay in the northern sky for quite a while, at least another month. We might be able to see quite a bit more of it than we currently can. Of course, it could do what they all do, which is dim and disappoint us. As I've said, it may not turn out to be anything in the end, but it can definitely be seen through a pair of binoculars. It is pretty small and it is on the move, so if you want to see it, what you need to do is either get a planetarium app on your phone or on your computer, or go onto one of the websites and check for a chart. They'll actually give you charts that show the position on each date, and you just really need to scan around with a pair of binoculars or a small telescope and you should be able to find it. A bit harder to find with a lot of go-to scopes because you need to have the actual coordinates entered. It won't be an object that you can necessarily look up. So that's, as I say, that's our comet. Again, just quickly take a look at the image that we took of it previously. As I say, so you can see this tail is streaking out quite. I'm going back again. Sorry, that was last week's attempt. See the tail streaking out here and fanning out. A bit harder to see in this colour image because there are fewer exposures. So that's Comet 2019 Y4. So really, I think we are pretty much done for the night. If you've got any questions, please just post them on our Facebook page and we'll try and answer them. We probably won't be doing another one of these just because they're getting later and later in the evening now that we're in summertime. It could be a little bit tricky, but we'll try again in the autumn, hopefully when we get some darker skies. We'll certainly, on the third Wednesday of the month, I believe that, let me just double check for you. That is 15th, Wednesday the 15th, we will be doing a public talk. Now we usually do these in Henry Dixon Hall at Whittam, and they're open to the public, but of course at the moment we can't run those events, so what we're actually going to do is we're going to do a talk online. We'll be streaming that one via YouTube rather than Facebook, so if you're interested, we'll post it on our Facebook page, we'll post it on our website, it'll be on our YouTube channel, and we should be able to tune in and see it on YouTube. Again, if you don't catch it, or if you missed any of this live astronomy session, then we will upload this to YouTube over the next couple of days and let you know again on our Facebook and on our website when it's available. As I say, any questions, please post them on our Facebook page and we'll try and answer them. Hopefully you can get outside. It should still be nice and clear. The moon's lovely tonight. Venus should still be visible. Pop out and take a look before you go to bed, and we'll catch up with you again soon. I hope you've enjoyed it, and thanks very much for your time and joining us tonight.